All right, welcome to our Regents review. We're taking a look at the course we learned so far. We'll also pick up at the end with a little review of some stuff for geometry next year. So, taking a look at day one, we're talking about properties and some statistics. So, first property we're going to talk about is when you change the order of what you're adding, but you still get the same result. So, if you remember this, this is the commutative property. And we want to say of addition here, okay, because we're adding things together. The next one, when we change the order when we multiply, this is the commutative property of multiplication. All right, the next thing, when we group things together and the parentheses move, but the actual terms, the numbers we're adding, stay the same, this is the associative property of addition, because we're adding here. And then likewise, when we do it with multiplication, that's the associative property of multiplication. All right. The next one is when we multiply the sum of two numbers by a third, it's the same as multiplying each. This is the commutative property, not commutative property, sorry, distributive property. And the important thing here is that we have to be multiplying and we have to be adding inside the parentheses, okay? That's what makes it distributive. If we add 0 to any number and we get the same thing, this is called the additive identity. All right, and the same thing when we multiply this time by 1. So we add 0 or multiply by 1. This is the multiplicative identity. All right. The product of multiplying any number times 0 and getting 0 is called the multiplication property of 0. Two quantities are equal if they are equal to the same thing. So if two things are equal to the same amount, then they're equal to each other. This is called the transitive property. And we'll see that a little bit in geometry as well. The sum of any number and its opposite is 0 is called the multiplicative additive. This is called the additive inverse. And when you multiply by the reciprocal and get 1, this is called the multiplicative. Multiplicative inverse. And the last one really doesn't have a property, but we just want to note it. When you multiply by -1, you change the sign. Not really a name for this one, so we're going to just kind of leave that one alone for now. Okay. All right, so just a couple of questions from past Regents questions based on this. So we take a look at the first one. When solving the equation, we ended up getting this. So what did she do in terms of properties to get from this to this? Now, when you add the same amount to both sides, okay, so here we can see we added the 9 from this side, disappeared, and went over here and became 16. This is called the additive property of equality, the addition property of equality. So something that's not on the list. Okay, we'll do some algebra proofs after our review for algebra as well to get ready for geometry. 2, when solving an equation, you can see what's going on here. The first step he did was, and you can see all he did was basically multiply that 2 through. So that would be the distributive property of multiplication. And this is over subtraction because we're doing it with the subtraction step. Okay. Kind of a formal, funky thing, but distributive property is the key thing we want to look for there. All right. So measures of central tendency, remember, if you remember, is mean, median, and mode. So mean is the average. You add up all the numbers, divide by the number there are. The median is the number that's in the middle. So this, for the median, you would normally arrange them in order, from smallest to greatest, okay? And then find the number in the middle. If there is one number in the middle, it's the median. If there's two numbers, the average of those two numbers is the median. And the mode is the number that appears the most often. Now, in a frequency table, to find the median, you would add up all these frequencies and then divide them by 2, okay? And that will tell you the number, the interval, technically, that's in the middle, where that number occurs. So here, if I add up 5, 11 is 16, plus 9 is 25, plus 4 and 6 is 35. So if I took 35 and divide it by 2, I would get 17.5. So we're the 17, between 17 and the 18th term, okay? And usually I think we round up here, but you can take a look. 5 and 11 is 16. So the next 17th and the 18th term are both going to fall where this 30 to 39 is. So the interval that contains the median is going to be this term. That's where the middle number is going to occur. Normally we would take the average of those two numbers, so that's where it's coming from. The modal interval is which one has the highest frequency. So here that would be 40 to 49, okay, and we would do stuff like that. Now, if you remember, your calculator will help you do mean, median, and mode as well. So for number 1, when it says interquartile range, the median, the mean, we would want to use a calculator here, okay? So what I'm going to do is get the calculator ready for you guys. I'm going to pause it for a second, and then we'll take a look at these two. Okay, so I went ahead and loaded up the calculator, and I already typed into the two windows the data, and I labeled this one as X and this one as Y so that we could easily tell the difference between them. But normally, if we're doing one question with one list, you don't have to name the column. Okay, so to run our 5-number summary here, we're going to go to Menu, Statistics, Stat Calculations, and we're going to do one variable statistics. Okay, I'm going to go ahead and enter for number of lists. And for normally I would just use column A. I'm going to select the variable that I labeled, which was X. The frequency is 1, meaning they appear one time each in the list. Okay, and then it's going to appear in the next column over in B, and we'll go ahead and click enter. Okay, so we want to check the interquartile range, the mean, median, mode. So if we scroll down, the mean you can see is right here. That's 86.8. So the mean for the other one is 87. So the second list is a little bit higher. All right, and then if we scroll down, we have the standard and the sample and the standard deviation. Now the sample is if you have an entire population of people and you're only picking some of them or a subset of them, that would be a sample. But if you are taking as many scores as there are, if it's a whole class, then you would use the population, which looks like the side by 6 here. Okay. And if we keep going down, we can see our 5-number summary. So minimum, the first quartile, which is, if we know where the median is, the median of the bottom half is the first quartile, okay? The maximum, third quartile, and remember the median is actually also referred to as the second quartile as well. So the interquartile range of 1 is greater than for semester 2, okay? And we can actually compare that if we scroll down here as well. So here we can see the interquartile range here is 4, and over here it is from 80 to 92 at 12. So 1 is greater than 2 is true, okay? The median score for 1 is greater than 2, and so once again we could check that one, right? We mentioned that before. The median is 86.8, and for semester 2 it was 87, so that is false. All right. The mean, sorry, we meant to check the median score for 1. That's down here. So 88 for 1 and 88 for 2, they're equal. Okay, the mean for 2 is greater than for 1, and the third quartile for 2 is greater than the third quartile for 1. So once again, the third quartile is 92.5 for 1. For 2, it's 92, so that's not true. So then we're just going to choose the one answer that is the most appropriate. All right, so if we go back, we take a look at the interquartile range. I think I did this wrong earlier. This is 12, 80 to 92. And for number 2, it's also 12, 80 to 92 for 80.5. So we can see that this is actually false, okay? The median score for 1 is greater than 2. So the median is 88. Here it's 88, so this is also false, okay? The mean score for 2 is greater than the mean score for 1. And so once again, we can scroll back up. We get mean for, this is for 1. Here's the mean for 2. So 2 is greater than 1. So this answer is correct. And just to check, The third quartile for 2 is greater than for 1. To go back down, we would see the third quartile is 92 here. And for here, it's 92.5, so that's false. So choice 3 would be the most appropriate. Okay, and then we can do the same thing for A and B. So once again, I'll type these in and then we'll compare. Okay, so we're comparing, first of all, the mean and then the standard deviation. So we're gonna go ahead and take a look. This is for group A, and we can see the mean is 6, and for group B, it's 6.875. So we wanna know where group B is bigger than A. So that would be 1, 2 is A is bigger, right? And 4 is A is bigger. So then we wanna know, is the standard deviation of A bigger or smaller? Okay, so if we scroll down, we get our standard deviations here. Okay, so there's B, and if we scroll down, here's A. So it's 3.8 and 3.16 for A, and for B, it's 3.27 and 3.05. So both of them are smaller for B than they are compared to A. Okay, so it doesn't matter if we use population or sample, we said that A is going to be larger than B here. So 27.05, 38.16. So A is bigger. So we want to pick choice 3 where A is larger. Okay, and that's how you're basically using your statistics there. Okay, for box and whisker plots, you're going to do the same thing we just did. We're going to type in our data and statistics. We're going to run our one variable statistics here, and then we're going to use the 5-number summary, once again is the minimum, first quartile, median, third quartile, and max. And we're going to go ahead and graph it on our number line here, okay? So if we look at the run through of how to do it is right here. And we're going to go ahead and take a look at the first question. So number 5, the third quartile, if you remember, it's minimum, first quartile, the median or the second quartile, the third quartile, and the maximum, okay? And this is assuming here, we're not assuming, we're given the fact that there are no outliers. So 90 would be the third quartile, and we would want to pick choice 2. All right, number 6, we're going to actually do ours. Now, although it has 3 weeks, this is all the same sorts of data. So he collected the data over 3 weeks, and it's shown below. So don't think it's 3 separate lists. We're using, for all 15 values, we're using this as one list. So I'll go ahead and type it in, I'll look at the 5-number summary, and then we'll do it together. Okay, so we went ahead and typed that data into our list. So once again, we're going to go to menu, statistics, choice 1. We're going to let column A, since we didn't name it, be our X list. Okay, the frequency is 1. And then we're going to, wait a minute, I think we did the wrong list. Menu, statistics, stat calculations, one variable statistics with one list. So A is going to be our X list. Frequency is 1. We want the data to show up in column B, and then we scroll down to get our 5-number summary. And so it's 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay, so we can go ahead and do that. Now we can also add a page, go to data and statistics. We're going to go ahead and click we're going to name our variable first. So let's go back a page. And we'll name our variable here as, let's say, X. Okay, so then when we go to the other page, we can now choose the variable to be X. And we can go to menu, plot type, and we can choose a box plot, and it will show us the box plot. And if there's an outlier, it will also mark it for us. So now we have our scale, we have the box plot showing up, and now we're good to go. So basically, we just need to choose numbers between 1 and 5. So let's choose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And our data, if you remember, is just 1, 2, 3, 4, and 5. Easy enough. So I'm going to put a dot at 1. Okay. I'm going to put another dot at 2, 3, 4, and 5. So this is our minimum. Here's our, just going to make that a little bit lower. Minimum, first quartile, median, third quartile, maximum. Okay, so all I'm going to do is draw my line going between the minimum to the second quartile. Okay, or the first quartile, same thing here. We're going to draw our box and then a line through the middle, and there is our box plot. Okay, types of distribution. So once again, a symmetrical distribution means it is a mirror image on both sides, pretty close to it, okay? And the mean, median, and mode are all falling right on along that line in the middle. They're basically the same. If we're skewing to the left, which means the tail is on the left-hand side, okay? That means that the mean is the smallest thing here, because it usually stays in the middle. The median then moves a little bit to the right, and the mode would be the furthest to the right where the peak of this is. Okay, so the mode is the biggest, followed by the median, and the smallest is the mean. If we are right skewed, okay, so our tail is on the right side, okay, it's a long tail, so it should be pretty dramatic. Once again, the mean is now going to be the biggest because it's in the middle, furthest to the right. Then the median, and the mode, which is the peak again, is going to be the smallest. All right. For symmetrical distributions, we can use the mean as the appropriate choice, and for skewed, we would want to use the median, okay, because that was going to report like the best average for us here, okay, the best middle number. So Noah conducted a survey on sports participation. He created the following two dot plots representing the data below. Now, this is tough to tell here. You can pretty tell that this is definitely going to be left skewed. Here, it's kind of tough to tell. So what we want to do is we want to answer the question below. The data for soccer players is right skewed. Kind of hard to tell based on the data because there isn't a big peak, and here there is kind of a little one here. So it's not like a big dramatic one of these like there is here. We can definitely tell it's kind of skewing that direction. All right, the data for soccer players is less spread for data of basketball players. So we can kind of say that they're about the same. The spread's sort of the same. So I would probably say that that's not true. The data for basketball players is the same median, and the data for basketball players has a greater mean. So we can actually figure this out and count that, right? We can add up these numbers, and we can do the mean, median, and mode to compare these, okay? So we can add all these numbers together and divide by the total number, and we can actually get the mean for both, and we can actually count where the median is. So let's just do the median. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if there's 18 numbers, the median is going to be halfway through or the 9th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is represented by these two dots. So the median is going to be 8.5 here. Okay, and I'm assuming it's the same number here. 2, 4, 6, 8, 10, 12, 14, 16. It is 18 again. So the 9th dot on both ways, 1, 2, 3, 4, that's 8. There's 9, okay? And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median here falls within the 10th number. So we can see the median for basketball players, right, is actually greater than the median for soccer players, right? They don't have the same median. So this is out. So it's definitely going to be the mean that's greater for basketball players than for soccer players, which should make sense in this case because most of the data is appearing on the greater side where you would say kind of this is a little bit evenly spread. Maybe there's a little bit more over on the smaller number. So the median or the mean should be slightly to the right compared to this one. Okay. All right. Creating dot plots, box plots, and histograms. All right, so what we're going to basically do for, we just looked at is we're going to put our data in, okay? We're going to go ahead and choose our type of plots. We're going to do box plot, histogram, whatever. And then we're going to just, after we do our data and statistics page, we're going to open up our, we can just show you. We're going to go to this is where we enter our data. This is data and statistics. And this one that we're going to add here, okay? After doing lists and spreadsheets where we put our data in, data and statistics is what allows us to actually create the graphs. So enter your data, choice 4. The graphs we're going to do is going to be in choice 5. All right. So we want to do the height of former Knicks players. Using the heights, we want to create a frequency table at right, and then we're going to draw the histogram. Okay, so I'll go ahead and enter the data and do the frequency chart. You guys can do that on your own as well. And then we'll go ahead and do the frequency table below. Okay, so I've gone through and marked off and tallied up our frequency. Now, if we count the number of entries here, okay, and we add up our frequency, that number should match. So we want to be careful to make sure we do that. All right. And then I went in and entered the data here into the calculator in the first column. We're going to want to call this something. So we'll give this a Z, any variable we want that we haven't used in the other two windows. And then we're going to go ahead and I'm just going to go Control Up, and I'm going to delete these two other windows so that we don't have any conflicting data here. All right. And so we're going to go ahead and hit Control. We're going to add a new page. So Control Doc, and we're going to go to choice 5 for our data and statistics. We're going to go ahead and select Z for our variable, so we get our dot plot to form. And then we're going to go over to plot type. We want to choose histogram. And here we can see this is the histogram based on using 0.1. Our intervals are given to us from 6 to 6.1 and so on and so forth. So we need 1, 2, 3, 4, 5, 6 intervals. Okay, you can see we have spaces here, 2, 4, 6, 8, 10, 12, 14, 16, that's like 18. So I think we can go, we'll start here and we'll go every 2, okay? And the reason I'm skipping the first one is because since I'm starting at the number 6 and I'm not including 1, 2, 3, 4, 5, I need a small break here, okay? So we do our little lightning bolt to indicate that we have a break in the axis. So here's 6 to 6.1, 6.1 to 6.2, sorry, 2 to 3, 3 to 4, 4 to 5, 5 to 6. We're doing that wrong. 6 to 6.1, 6.2 to 6.3. So we're going to do this way. 6 to 6. I broke it. To 6.1. I'm trying to write sideways on this and it is not working, people. Okay. Okay, 6.2. And so what I'm going to do for my purposes is I'm going to make this really big, and then it'll be easier to write inside of it. 400%. All right. So 6 to 6.1, 6.2 to 6.3, 6.4 to 6.5, 6.6. Yeah, that's not a 6. To 6.7, 6.8 to 6.9, and then 7.0 to 7.1, and I believe that is it. 1, 2, 3, 4, 5, 6. Yep. Okay, so now I'll go back to normal. Scroll back up, and then we're going to go ahead and do our actual histogram. So the first frequency we have is up 3. So once again, we're going to not label this axis since we're counting by 1s here. We could count by 2s, okay, and do that. This is 1, skip a few, 2, skip 3, skip. Here's 4, skipping 1, 5, skip to 6, skip to 7, skip to 8, skip to 9, skip to 10. But I do have 11, so I can't actually do that. We're going to count by 1s. Nice and easy. So I'm going to go up 3 for the first interval. 1, 2, 3 boxes and come back down. Then we're going to go up to 10. So we can go 1, 2, 3, 4. Here's 5, 6, 7, 8, 9. Here's 10. Here's 15. So the next one is going to go all the way up to 10. The next one goes up to 11. So the histogram is like a bar graph. Remember that the bars actually do touch. Okay. 6.6 to 6.7 is 0. We're going to leave that blank. 6.8 to 6.9 is 2. And then 7 to 7.1 is 3. And you can shade in your graphs here. Okay, the important thing we need to do besides this is we need to label our graph. Okay, so remember these are heights. Well, we should say, we shouldn't necessarily label, all right, heights of basketball players. You can label the whole chart of b-ball players. Okay, the interval on the bottom, the frequency on the right. So this is frequency, we need a Q here, not a G. Frequency, here's our interval. I'm running out of room, so RVAL, and we're good to go. All right, and that is it for today, guys. See you tomorrow for day 2.